Yeah, okay, now we're going to do De Morgan's law on quantifiers. Okay, this is going to be probably the last thing that we do today. So here's the universal quantified statement. I think this would clear every confusion that you have for quantifiers and their negations. Okay, cool. So our example is that every student in this class has taken a calculus. Okay, and this is how we write it. For P of x means x has taken calculus. Okay, when I say for all x P of x, I mean that everyone in this class has taken calculus. Okay, stop me at the moment I stop making sense. Okay, किसी point पे आपको लगे कि ये वाला point मुझे नहीं समझ आ रहा, stop me there. Okay. Alright, so this is what it means, that it's true for this guy, it's true for this guy, it's true for this guy. Okay, it's true for every member of the class. Okay, that's the definition of universally quantified statement. Moving on. What's the negation of the above statement? What's the negation of this thing? That's not what the negation of this thing is. So let me kind of go back to our first class जिसमें हमने negation define किए थे. Okay, negation of a proposition is another proposition जहाँ पे it's false when the original statement was true and it's true when the original statement was false. Okay, it's direct opposite of the truth table of the statement. Okay, that's what negation is. So now I'm asking, what's the negation of for all x P of x? Okay, let's see, how do I do it on slides? It's not true. Okay, if I write this thing, it's not true, I get the negation of the statement. Okay, okay. So let's write it down in a very simple way. It's not true that every student in this class has taken the calculus. What does it mean? This means that there is at least one student that has not taken the calculus. So far with me? Yes. Everyone? Okay. So how do I write this thing now? There is at least one student that has not taken the calculus. I write it using, I mean, this is simple, right? There is at least one student. At least one का मतलब ये है कि I can use existential quantifier now. Okay, and what's this? Not taken calculus is the just negation of P of x. Okay, P of x says x has taken calculus. Not P of x says that x is not taken the calculus. Okay, so this is simple now. I can write it down as this happens, or this happens, or this happens. Oh. Okay, so I get there exists x negation of P of x. Okay, are we good? Please stop me if I'm not making sense. Okay, let's move on. Negation of quantifiers. So negation of for all of x is equal to this. This is the definition of for all x. This thing is equal to something else. Let me. This thing is equal to by De Morgan's law, जो हमने देखा था अभी. This is equal to this. Okay. Remember De Morgan's above apply करते हैं. You negate every statement जो अंदर है, and you flip the operator जो आप use कर रहे थे. Okay. So I negated P of x1, I negated P of x2, negated P of x3, and then I flipped all the operators. Okay. यहाँ पे and operator था, तो I would have or operator here. Okay. And this is equal to the there exists x, not P of x. Okay. And this is now equal. Okay, so I've just kind of proved that negation of for all x P of x is equal to there exists negation of P of x. Awesome, good. This is the kind of arguments I expect when I give you propositions to prove or disprove. Okay. So let's see how we deal with the negation of an existential quantifier. Okay, negation of existential quantifier means that it's not true whatever existential quantifier says. Right? Let's do that. So it's negation of P of x x1 or p of x2 or p of x3 and so on. Okay, everything within the parenthesis. Okay, अब यहाँ पे आप DeMorgan's apply करेंगे तो what do you get? Yeah. Again, you are 2 steps ahead. But what I'm saying is that you would negate everything within the parenthesis, and then you flip the operator. Awesome. This is what you get. Okay. And अब यहाँ पे you have a bunch of statements और उन सब के बीच में and लगा हुआ है, which means that this is equal to for all. Okay. So it's for all x negation of p of x, whatever you said a moment ago. Okay. All right. Are they good? Okay.